Hello everyone, this is Ayan Mukherjee. In the today's session, we are going to talk about object-oriented programming concepts, commonly known as OOPS concepts in Java programming language with real-time examples. As we all know, object-oriented programming concepts are very important nowadays. So, irrespective of a programming language, we must understand in-depth knowledge on OOPS concept. Whether we are running Java programming language, Python programming language, .NET, PHP, but the OOPS concepts are mandatory. Without having an idea about OOPS concept, we will not able to design the systems in object-oriented programming model. It simplifies the software development and the maintenance. Using the OOPS concept, we can develop the efficient and the reliable applications. This is the outline of my lecture. A programming model based on classes and objects is known as object-oriented programming model. In object-oriented programming model or OOPS, software is organized around objects rather than actions or logic. An object is an instance of a class and it encapsulates both data and behavior. The core concept of OOPS are objects and classes. The definition of object is it is an entity that holds data and methods. Each object is an instance of a class and represents a real-world entity or concept such as car, customer, etc. The definition of class is it is a blueprint or template for creating objects. A class defines properties and behaviors that its objects will have. For example, imagine a class animal where properties are name, age, etc. and behaviors are eat, sleep, etc. We can then create an object of the class animal like dog, cat, where each object has specific values for name and age. This approach allows for creating reusable, maintainable, and scalable software where interactions between objects are modeled after real-world scenarios. Now we will talk about what are the major object-oriented programming principles. There are four major object-oriented principles are encapsulation, inheritance, polymorphism, and abstraction. We will explain each one by taking real-time examples. First, we will discuss encapsulation. Encapsulation is a fundamental object-oriented principle in Java. Encapsulation means it is a process of binding data and corresponding methods in a single unit. A Java class is nothing but an encapsulation because in a class, data and corresponding methods are binding together. Using encapsulation, we can achieve security that is nothing but data hiding as well. The provided code defines a simple Java class named student. The student class demonstrates encapsulation by restricting direct access to the name field and providing controlled access through the setName and the getName methods. Now, the next principle is inheritance. Inheritance is another major concept in object-oriented programming. Inheritance is a technique where we can create a new class by using an existing class functionality. One of the main advantages of inheritance is we can reuse existing code within the new applications. The provided code is an example of inheritance in Java, where the dog class inherits from the animal class. By extending the animal class, the dog class gains access to the eat method without needing to redefine it. In addition, the dog class can define the new methods bark, allowing it to specialize or add functionality. The next one is polymorphism. Polymorphism is another major object-oriented concept. Polymorphism means many forms where we can say that one method can take more than one form based on number of parameters or type of parameters. In simple terms, we can say that polymorphism means many forms. Real-time example is a person can behave differently based on location. For example, a person can behave differently at office, he behaves differently at market, and he behaves differently at home. In Java, there are two types of polymorphism are compile time polymorphism and runtime polymorphism. Compile time polymorphism is also called static polymorphism or method overloading, and runtime polymorphism is also called method overriding or dynamic polymorphism. Here, the provided example is a calculator class demonstrates method overloading, that is a form of compile time polymorphism in Java. Method overloading allows multiple methods in the same class to have the same name but different parameters, that is number or type of parameters. Here the button, that is plus or add button, is the same, but the behavior adapts a single method name to handle different input types or scenarios. The compiler determines which method to call based on the method signature during compilation. The advantage of method overloading is we easily extend functionality by adding more overloaded version of the method as needed. Next, this code demonstrates method overriding, that is runtime polymorphism or dynamic polymorphism. It is a core feature in Java. Method overriding occurs when a subclass provides its own implementation of a method that is already defined in its superclass. The method in the subclass must have the same signature, that is name, return type, and parameter as in the superclass. The code demonstrates how method overriding is used to implement polymorphism in Java, making it possible for the shape class to act as a general interface for all shapes, while subclass like circle provides specific behavior. The advantage of method overriding is it allows subclass to modify the behavior of inherited methods. The next concept is abstraction. Abstraction is a technique which hides the unnecessary data from the user and it only exposes the necessary data for the user. So the main advantage of abstraction is reducing complexity. To achieve abstraction in Java, there are two ways. One is abstract class, another is interface. This code demonstrates the use of abstract class. Abstract class allow us to define a common interface for all subclasses, making the code more organized and easier to maintain. Abstract classes can also include concrete methods, providing partial implementation that can be shared by all subclasses. By declaring move as abstract, the vehicle class ensures that every subclass defines its own specific behavior for move. This code effectively uses abstract class and method overriding to model a common interface, that is vehicle, and a specific behavior for its subclass, that is car. Now we compare object-oriented programming model with procedural programming model. Procedural programming, that is C programming, focuses on organizing code into functions or procedures that operate on data. It emphasizes a step-by-step sequence of instruction to achieve a goal. But on the other hand, object-oriented programming, that is Java programming language, focuses on organizing code into objects which are instances of classes. These objects bundle data or attributes and methods or functions together, promoting reusability, modularity, and easier maintenance. In short, we can say procedural programming centers on actions or functions, but object-oriented programming centers on objects and interactions between them. Now we highlight on real-world applications using OOPS. In software development, object-oriented programming is used to design complex systems like banking systems and customer relationship management (CRM) software, where data and behavior are modeled as objects for better organization and scalability. In mobile applications, OOP is crucial in Android development as it helps structure the app's components like activities or services as objects that interact with each other. On the other hand, for game development, Unity uses OOP to manage game logic, where characters, items, and environments are represented as objects with properties and behaviors. As a summary, we can say that Java's object-oriented programming features such as encapsulation, polymorphism, inheritance, and abstraction make software development simpler and more efficient by organizing code into reusable modular components, and mastering OOPS in Java enable developers to create scalable, efficient, and robust applications, unlocking the full potential of modern programming practices. This is the basic object-oriented principles. Thank you.